Hi everybody, and once again welcome to Pankaj Sir's Echelon tutorials. In this today's session I am going to continue with the IBDP session on physics that we had already started with that first chapter, that is measurement, physical measurement. Okay. And in the previous lecture, I had explained you about the physical quantities, the SI system, the order of magnitude, etc., etc. Okay. Today I'm going to deal with something called Fermi problems. Okay. Now this Fermi problems is something which is very interesting. Okay. And it makes use of mostly the order of magnitude. Okay. So once you know what is order of magnitude, okay, you will definitely understand these Fermi problems very nicely. So order of magnitude is something that you should know for the Fermi problems. Okay. Now let us take as example number one this Fermi problem. So some four Fermi problems I'm going to explain today, or I'm going to discuss with you people. Okay. So let us see how you find it. Okay. So the very first example is this one. Suppose if 5 meter depth, okay, wears off every 60,000 kilometer of a car tire. Okay. So suppose you have a car ka tire. Okay. Now this is a tire of a car. Now this car, when it is running on the roads, after traveling say 60,000 kilometer, the 5 millimeter of this particular tire, so depth, 5 meter depth of this particular tire is worn out. That is what he has to say. Okay. Worn out means it is undergoing wear and tear. Okay. So that is happening with this car tire. That is the statement. Now, the information here is given is if the radius of the tire is 30 centimeters. So suppose the radius of this particular tire is say 30 centimeter. Okay. And the question asked is what will be the order of magnitude of the wear of the tire in millimeters for one revolution. Okay. So this is the question. You have to find the order of magnitude for what? For the wear taking place in millimeters in one revolution, in just one revolution. Okay. Information given to us is in 60,000 kilometer distance traveled by the car, the that has taken place is 5 millimeter. Okay. Chalo. So let us start working on this solution. First of all, what I will do is this 60,000 kilometer, I am going to convert it slowly into millimeter, step by step into millimeter. So 60,000 kilometer is nothing but 6 into 10 raised to 7 meters, right? 6 into 10 raised to 7 meters. Now, this will be converted into centimeter, like 6 into 10 raised to 9 centimeters. Okay. And now it will be converted into millimeter as 6 into 10 raised to 10 millimeter. I hope this is understood by you people. Okay. It's basic conversions, right? So 60,000 kilometer, when I convert it into meters, it becomes 6 into 10 raised to 7 meters. Then that will be getting converted into 6 into 10 is to 9 centimeters, and that will get converted into 6 into 10 is to 10 millimeter. So 60,000 kilometer is nothing but 6 into 10 is to 10 millimeter. Now why I converted this into millimeter? Because we want the order of magnitude of the wear of the tire in millimeter. Okay. So that is why I converted this distance travel in millimeter. Fine. Now here is the tire that I am trying to show you, and the radius of this tire is 30 centimeter, and this is the road on which it is traveling. And suppose this tire makes one rotation or one revolution. After one revolution, okay, what will be the distance traveled by the tire? This will be the distance traveled, and this will be nothing but 2 pi r, that is equal to the circumference of the tire. So if you want to work out 2 pi r, the answer will be one revolution. In one revolution, the distance covered by the tire will be 2 pi r. And 2 pi r is 2 into r is 30 centimeter, right? So it will be 2 into 30, that is 60 pi centimeter. But this also I will not keep in centimeter because this distance I have converted into millimeter. So this also I will have to convert into millimeter, right? So 60 pi centimeter, if I want to convert it into millimeter, it is going to be 600 pi millimeter, right? So the 600 pi millimeter can be written as 6 into 10 raised to 10. Okay, is that clear? No, sorry, this is 600 pi millimeter, right? Now, if you see this relationship, one revolution is equivalent to 600 pi millimeter. Okay, one revolution is equal to 600 pi millimeter. And we know that the car has traveled 60,000 kilometer. That is 6 into 10 is to 10 millimeter. So 6 into 10 is to 10 millimeter will correspond to how much revolution? Okay. So this will give us the answer to how much revolution has taken place in this 60,000 kilometer distance that the tire has traveled. Okay. So the answer for this will be 6 into 10 is to 10 multiplied by 1 divided by 600 pi. Okay. So the answer will be 60,000 kilometer is 6 into 10 is to 10 millimeter. This is already discussed. One revolution is 600 pi millimeter. That is already discussed. So how many revolutions will take place in 6 into 10 is to 10 millimeter? And the answer will be 6 into 10 is to 10 into 1 divided by 600 pi. This should work out to how much, see, this 6 and 6 will cut, and 10 is to 10 divided by this 10 square. Okay, that is 10 is to 2. It will work out to 10 is to 8 divided by this pi. So this many revolutions is the answer. Okay, so what is the number of revolutions in 60,000 kilometer? So in traveling 60,000 kilometer, the revolutions made by the tire is 10 is to 8 upon pi. Okay. Now, what is the question? Let us see what is the question. What will be the order of magnitude of the wear of the tire? We are not supposed to find out the number of revolutions. Okay. We have to find out what is the wear taking place in the tire in one revolution. So, in traveling 60,000 kilometer, the number of revolutions was 10 is to 8 upon pi. Now, let us come to this second statement. 5 millimeter is the wear taking place for 60,000 kilometer. Now 60,000 kilometer is equivalent to 10 is to 8 upon pi revolutions. So 5 millimeter wear is taking place for this many revolutions. How much? 10 is to 8 upon pi. So for one revolution, what will be the wear? Okay. So to work out this, you'll have to cross multiply 5 into 1 divided by this. So 5 into 1 divided by 10 raised to 8 upon pi. This will be the answer. Okay. This will be the wear in millimeter. Now this, if you work out, it will be 5. This pi will go up. So it will be 5 into pi. That is 5 pi. And this 10 raised to 8 will go up and it will become 10 raised to minus 8. So the answer will be 5 pi into 10 raised to minus 8 millimeter. Okay. This is the wear taking place for one revolution. Now let us try to bring this in the scientific notation form. Okay. So this 5 pi can be written as 15.707 into 10 is to minus 8 millimeter. Fine. Now this 15.707 is not in the scientific notation form. For that, I'll have to bring this particular 15.707 in the form of a number which is between 1 and 10. So if I do 1.5, okay, then it will get converted into 1.5 into 10 is to minus 7 millimeter, right? Now, since this 1.5 is less than 3.16, therefore, the order of my magnitude for this wear taking place in one revolution will be 10 is to minus 7 only. Okay, so it will be 10 is to minus 7 millimeter per revolution. So this is my answer for the very first question. Okay, so what is the order of magnitude of the wear of the tire per revolution? The order is 10 is to minus 7 millimeter per revolution. So this is how Fermi problems are to be dealt with. Okay, let us try to solve this second Fermi problem. Okay, example number 2. In this, he says a car tire has a radius of 30 centimeter. It runs for a distance of say 250,000 kilometer. Now its tire is junked. So after running 250,000 kilometer, the tire is in the junked position. Okay, junked position means now you have to either replace it or you have to just throw it out. Okay. Now, how many revolutions has the car tire made before it junked? Okay. So this question is, you have to find the number of revolutions before the tire gets junked. And the tire gets junked after traveling 250,000 kilometer, right? And the extra information given is the car tire ka radius is 30 centimeter. Now let us see how to work out this. Radius of the tire is 30 centimeter. So the circumference of the tire will be 2 pi r. That will be 2 pi into 30 centimeter. That is equal to 60 pi centimeter. So this is the circumference of the tire. Fine. 60 pi centimeter. Now, the distance traveled by the tire is how much? The distance traveled by the tire is given as 250,000 kilometer. Now, this 250,000 kilometer can be written as 25 into 10 raised to 4 kilometer. Now, this 10 raised to 4, 25 into 10 raised to 4 kilometer, if I convert it into meters, it will work out to 25 into 10 raised to 7 meters, right? And if I want to convert it into centimeter, it will be 25 into 10 raised to 9 centimeters. Is that clear? So the distance traveled by the tire is given in centimeter as 25 into 10 raised to 9, and the circumference of the tire is given as 60 pi centimeter. Okay. Now, we know that the number of revolutions made by the tire is always equal to the total distance traveled divided by the circumference, provided the units of both are the same. Okay. So distance traveled I am taking as 25 into 10 is to 9 centimeter, and the circumference of the tire I am taking as 65 centimeter. Now since the same unit I have taken in numerator and denominator, okay, so the units will get cut out and you will get the answer as 5 into 10 is to 9 upon 12 pi. This is the answer. Okay, it's a pure number. Now this will work out to 0.1326 into 10 raised to 9. If you work out this 5 upon 12 pi, if you work out this separately, 5 upon 12 pi, you will get 0.1326 into 10 raised to 9, right? Now this 0.1326 is not in the scientific notation form. Why? Because 0.1326 is less than 1. This particular part of the scientific notation should be between 1 and 9. So what I'll do, I'll shift this decimal 1 on the right hand side. So it will become 1.3. Now, if I do that, if I shift this decimal on one place to the right, okay, this 10 raised to 9 will become 10 raised to 8. So, this particular answer can be written as 1.3 into 10 raised to 8. Now, this is in a scientific notation form. So, because this 1.3 is less than 3.16, 1.3, this part, 1.3, because it is less than 3.16, therefore, this will be the order of the magnitude of the number of revolutions. So 10 raised to 8 will be the order. So order of magnitude of the number of revolutions is 10 raised to 8. Since it's a pure number, no units. Okay. Now this is because 1.3 is less than 3.16. Okay. This 3.16 is nothing but root 10. Okay. This is how you get it. Fine. So that was example number 2. Let us move on to example number 3. Example number 3 says that assuming that the population of Earth is 6 into 10 raised to, how much is this? 1 second. 10 raised to 9. Okay. So the population of the Earth is 6 into 10 raised to 9 people. Each person, when he stretches out his hands on both the sides, okay, it covers a distance of 1.5 meter. Now, what would be the length of the line created by all the people of the earth? How many people? 6 into 10 is to 9 people. This many people, if they hold hands stretched out on both the sides, and if they try to make a chain, so what will be the length of this chain? That is the question. Okay. Now, the length of the chain would be how much? Now, one human being, one person, when he stretches out his hand on both the sides, that covers a distance of 1.5 meter. That multiplied by the number of total people, that is 6 into 10 raised to 9. This will give you in meters the length of the chain formed by this many people. Okay. So a long chain of length 1.5 into 6 into 10 raised to 9 meter will be formed. Now 1.5 into 6 is nothing but 9. So this can be written as 9 into 10 raised to 9 meters. So this is the length of the chain that can be formed, 9 into 10 raised to 9 meter. This is in the scientific notation form. And since 9 is greater than 3.16, your order of magnitude will become 10 raised to 9 plus 1. That is 10 raised to 10. So the order of magnitude for the length of the chain is 10 raised to 10. Okay. Now, the order of the magnitude of the length of the chain of people is 10 raised to 10 meter. That is concluded. Now, further the question goes ahead and it asks you to find out how many times this chain would wrap the earth around. Okay. So for this, you should know what is the circumference of the earth. For that, you should know what is the radius of the earth, isn't it? So radius of the earth can be taken as 6 into 10 raised to 6 meter. Okay, this information I can give you. Radius of the earth can take it as 6 into 10 raised to 6 meter. This information is also given. Now with this information, I can find out the circumference of the earth. So circumference of the earth is equal to 2 pi r. So 2 pi means 6.28 multiplied by radius. So radius is nothing but 6 into 10 raised to 6 meters. So 6.28 into 6 into 10 raised to 6 meter will be the circumference. If you work out this, you will get 37.66 into 10 raised to 6 meter. Okay. Now still if you want to convert it into scientific notation form, you can write this as 3.7 into 10 raised to 7 meters, right? 3.7 into 10 raised to 7 meter. Now this is the circumference of the earth. Now the number of turns that the chain of this human being, okay, this 6 into 10 raised to 9 people, they have formed a chain. So that chain will go round the earth how many turns? That number of turns, if you want to find out, then that will be equal to the length of the chain formed. So length of the chain is 9 into 10 raised to 9 meters divided by the circumference of the earth, and the circumference of the earth is this 3.7 into 10 raised to 7 meter, or roughly you can say 4 into 10 raised to 7 meter. So here I'll take 4 into 10 raised to 7 meter. Okay. So this will give you number of turns. The total length of the chain in meters divided by the circumference of the earth in meters. Now meter and meter will cut out, and this if you calculate 9 upon 4 you should get 2.25, and 10 is to 9 upon 10 is to 7 will be 10 square, and 2.25 into 10 square will be 225 times. Okay, or roughly you can say 200 times. So the number of turns that the chain, this human chain, will have to be going around the earth, okay, around this equator, okay, will be how much? 200 times. Okay. So this is the answer for the third type of the Fermi problem. Now let us come to the fourth type of a Fermi problem. Okay. Now this fourth question says that estimate the speed with which human hair grows. Assume that a person cuts hair every 2 months, and assume that the barber cuts the length of about 2 centimeter. Okay, which is nothing but 2 into 10 raised to 2 minus 2 meters, right? So here they have asked you to estimate the speed of the human hair growth. So speed is equal to distance or length divided by time. Now distance or length should be in meters. So the length of the hair that is cut by the barber is 2 centimeter. So if I want to convert it into meter, it will be 2 into 10 raised to minus 2 meter. So length I can take as 2 into 10 raised to minus 2 meter. Divided by time. Now the time is 2 months, because every 2 months the person goes for the haircut. So 2 months means 30 into 2. Okay, 30 is the number of days in 1 month. So 2 months means 2 into 30. And in 1 month, you have 30 days. So I have taken this 30. And in 1 day, you have 24 hours. So I have taken this 24 hour. In 1 hour, there's 60 minutes. And in 1 minute, there's 60 seconds. So when you multiply this out, 2 into 30 into 24 into 60 into 60, this will give me the time in seconds. So in 2 months, how many seconds are there? This many seconds. So let us go further and cut this 2 and this 2. Okay, 2 will cut. I'll get 10 raised to minus 2 meter, and in the denominator I'll be left with 3 into 36 Now this 30 has been split into 3 into 10, right? So it is 3 into 36 is this 6 are 36, and then this 3 zeros 1 2 and 1 from that 30. This 30 makes this 10 raised to 3, and you are left with 36 and a 24, right? So this is also, this is in seconds, right? Now this 2 cut होने के बाद you are left with 10 raised to minus 2 meter in the numerator, and in the denominator you are left with 3 into 36, and this 24 can be written as 2.4 into 10 raised to minus 1, and that along with 10 raised to 3, when you multiply out, it will become 10 raised to 4. Okay, 24 can be written as 2.4 into 10, right? 24 can be written as 2.4 into 10, right? So that 2.4 I have taken, and this 10 is to 1 I have multiplied with this 10 is to 3. So that makes it 10 is to 4, right? So this is seconds. Now you get 10 is to minus 2 meter upon 3 into 36 into, now this is 2.4 into 10 is to 4, right? So 2.4 can be rounded up to 2, right? I can write 2 instead of 2.4 into 10 is to 4 seconds, right? Now this will work out to 10 raised to minus 2. This 10 raised to 4, if I take up in the denominator, it will become 10 raised to minus 2 minus 4, right? That happens to be 10 raised to minus 6. So in the numerator, I get 10 raised to minus 6, and in the denominator, I get 3 into 36 into 2. That is 3 into 72. And 3 into 72 works out to 216. So finally, I am left out with this 10 raised to minus 6 upon 216. Now what I do is 1 upon 216 on the calculator, I try to find out, and I get the answer as 4.63 into 10 raised to minus 3. This is the answer for 1 upon 216. Okay. 1 upon 216 is this, what I get, 4.63 into 10 raised to minus 3. That I will have to multiply with this 10 raised to minus 6. Okay. Now this will work out to 4.6 into 10 raised to minus 6, and minus 3 is minus 9. So I get this as the answer, 4.6 into 10 raised to minus 9. Now, because this 4.6 is greater than 3.16, what will happen to the order of magnitude? The order of magnitude will be increasing by 1. So it will become minus 9 plus 1. And this works out to 10 raised to minus 8. Now this is the order of magnitude of the speed, and the unit is meter per second. Okay. So the estimate speed of human hair growth is how much? It is in the order of 10 raised to minus 8 meters per second. So that was example number 4. And with this, I'm going to wind up this today's video. In this video, I have explained you 4 problems which come in the category of Fermi problems. Let me tell you what are these Fermi problems. Fermi is the name of a scientist, who worked out the all this order of magnitude and all that. He was the one who behind this order of magnitude discovery and all that, and that is why in short they call this as Fermi problems. And in all these Fermi problems, we make use of the concept of order of magnitude, okay, along with other mathematical concepts, and these are Fermi problems in short. So these were the 4 Fermi problems that I wanted to discuss with you, and with that I end this today's session, and I hope you liked my video. Okay, and if you happen to like my video, please subscribe my channel so that I'll be motivated to make more and more such videos. So see you next time in the next video. Till then, goodbye, take care all of you.